Hello everyone. Today I am going to discuss about asymmetric induction. It is also known as enantiomeric induction. Basically, what is asymmetric induction? Suppose we have a prochiral center like carbonyl here. So this is prochiral center, and we have also a chiral center at the alpha position. So asymmetric induction says the influence of that chiral center on that prochiral center, which determines the diastro-selectivity of that prochiral center. So this is basically asymmetric induction. Here this is prochiral center after addition of nucleophile like H minus or any other nucleophile, it will be chiral. The induction will also occur because of that group. So diastereomer will form, and it will be maybe above or below. So basically it will depend on that center. So this is all about asymmetric induction. Basically asymmetric induction are categorized into three parts. These are 1-2 asymmetric induction, 1-3 and 1-4 asymmetric induction. So first I am coming on 1-2 asymmetric induction. Yeah. So here you can see that there is also a prochiral center carbonyl. It is also called 1-2 carbonyl induction, and at the alpha position there is a chiral center. So 1-2 asymmetric induction basically happens when there is a chiral center at the at the beta position or 1-2 position with respect to that prochiral or carbonyl center. So basically what will happen? So H minus will attack here, and it will be OH. So basically there is a generation of chiral center. So I am showing you. Okay, let me change it. It is ethyl. Make it ethyl. Okay, it is ethyl, and there is, you can say, the methyl is above the plane. So there is also methyl. And zero hydrogen. So after addition of LAH, H minus will attack here and still go down. So you know the reaction mechanism and what will be the product. I am not showing this. This is basically Felkin-Anh model. So 1-2 asymmetric induction basically is known for Felkin-Anh model and for Cramp's model. So the diastro-selectivity will be determined by this center. So this is called 1-2 asymmetric induction. Now coming to 1-3 asymmetric induction. Here you can see that there is also a chiral center at the alpha, beta and gamma position. So this is gamma center. So influence of chiral center at the 3 position or gamma position with respect to carbonyl, this is called 1-3 asymmetric induction. So here we treat with this reagent in presence of TiCl4 and in DCM solvent at minus 78 degrees Celsius. So what will be the product? This is very important. So to determine the product, we first look at the transition state. If you see at the transition state, it is like basically 6-member like chair form, 6-member chair form. Ti will coordinate with carbonyl and the oxygen. So here oxygen is present and here carbonyl is present. So Ti will coordinate both of this. You can see this here, and here carbonyl, and this is the center where nucleophile will attack. So nucleophile will come here and this will go down. So what will be the product? Basically, if nucleophile may attack from this side and this side, if the nucleophile attacks from this side, it will go through the twist boat transition state, which is basically less stable, and if it is attacked from this side, it will go through the 6 cyclohexane 6 member CRTS, which is basically more stable than that of the twist boat form. So basically nucleophile will come from this side, and that's why the OH, after addition of nucleophile, it will convert it to OH. So OH will go to the down, that is OH will be below. So what will the product? Yeah, so you can see that OH is down. So why it is down? Because of the influence of this group. So this is basically 1,3 asymmetric induction, and this is also known as Ridge-Gillette model. Okay, fine. Now coming to the 1,4 asymmetric induction. Here you can see that there is also a chiral center at the alpha, beta, gamma, delta position or 4 position. So how will it influence? How will it influence, or it will influence like how? If you see at the products, it will give the receiving mixture. Actually the product will be third butyl group plus this is 50-50. So here you can see that there is no asymmetric induction, no selectivity, no diastro selectivity. Why this is happening? Because the structure is very flexible, because the chiral center is very far apart, because it is at 4 position, so it is little bit more flexible and the order is long. So that's why there is no asymmetric induction. We get the 50-50 ratio product. So lastly I am solving one question. Yeah, this is very basic. This is very basic thing I am giving you, but it is also important. Sometimes it is often asked during the interview session. So I am giving you one last question. If you solve it, yeah, you will okay. Here it is. So what will be the stereochemistry of that particular OH group? During an interview, one of the interviewers asked me this question. So I am giving you the mechanism. Yeah, this is the benzene, sorry. So first OH will attack here. That will be OAC. Pyridine is there, it will act like a base, so it will abstract proton from this, will be minus, goes down. This will be removed. Yeah, so this will happen, and after that we see further will attack here. So you can see that there is a double bond. Firstly, there is a chiral center and there is a double bond, that is alkene sp2 type. So OAC will attack from the both side, so the product will be like this. So there is no bond stereochemistry, you can see. But first of all, there is a chiral center, but after treating with Ac2 and in presence of pyridine, there is no bond stereochemistry. So basically I am trying to say that there is no necessity that there must be a chiral center. There is also a loss of chirality, but there is no environment. This is chiral position, but there is no adjacent chiral environment which may lost, which can influence this, but still it is here it is at a loss of chirality. So this is also one type of induction, asymmetric induction, not this type, but this is also different type. So thank you, that's all for the day. Thank you.